So for 9.2, developing formulas for circles and regular polygons. Chloe, what's one thing that you highlighted in this box? Okay, so one of your formulas for circumference is going to be 2 pi r. Okay, and then, Riley, what's the other one? What's the other one for circumference, though? Yes. Okay, so then we're going to write those out. So we can either do the circumference equals 2 pi times the radius. Okay, or we can do the circumference equals pi times the diameter. We're going to talk about why that is. So, do you guys remember what a radius is? Okay, yeah, Xavier, what is it? Okay, so the radius is always going to go from the center of the circle to the side. Okay, it has to go from the center to the side. Okay, and it is half of the diameter. Or you could also say the diameter is 2 times the radius, which makes sense because here you have 2 pi r. 2r is equal to d. Okay, that's why those two are going to be the same. Now, what is the diameter? How would you define the diameter? Yeah, Brendan?
1 point of the circle all the way across.
Okay, and there has to be one other specific thing in it.
It's straight. It has to go through the middle.
It has to go through the center, right? Okay, so the diameter is going from one side of the circle to the other, but it has to go through that center. Okay, and then Jared, what was the other formula we had in our box?
Area equals pi times radius squared.
Good, okay, so the area is going to equal pi times the radius squared. Okay, so for example 1, we're going to start finding measurements of circles. Now, a lot of times you are going to be leaving things in terms of pi, so pi is going to be part of your answer. Okay, so the relationship between the circumference and the diameter is this unit of pi. Okay, if you were to take different circular objects and measure their circumference, which really, the circumference is just the what of the circle? It's just the perimeter, right? It's the distance around the circle. Okay, if you were to divide that by the diameter of the circle, you should get pi. You should get 3.14, which is a very special number in math. So for example 1, we are going to find the circumference of circle M if the area is 25x squared pi feet squared. Okay, so we want to find the circumference, and we are given the area. Okay, so if we're going to find the circumference formula is 2 pi r or pi d. What's the only thing I have to know to be able to find the circumference of the circle? I have to know what the radius is. Okay, so our first step is going to be to use the area formula to find the radius. Okay, so we're going to use the area formula to find the radius. Okay, so we know that the area of a circle is equal to pi r squared. I also know what the area is. Okay, so the area is 25x squared times pi. Okay, so they tell us the area is 25x squared pi. The feet squared is going to tell you what your unit is for this. Okay, so the unit's going to be measured in feet. And we're definitely going to put that on at the end. Okay, so that's going to equal pi r squared. So remember, I'm trying to solve for r. All right, so Ethan, if I'm trying to get r by itself, what's one thing I should move over to the other side? Okay, yeah, how am I going to do it? Yep, so I'm going to divide both sides by pi. So pi divided by pi is just going to make what number? 1, right? So then I just have 1r squared, which is r squared. Now on this side, when I divide by pi, I do have pi here, so this is going to divide out as well. So then, Tanner, what am I going to be left with on the other side?
Pi over a.
That, nope, so because your pi's canceled out, right? Okay, so what's, yeah, the 25x squared. Right, now remember, we're trying to solve for r. So if I have r squared, then Tina, what am I going to do to both sides? Yep, take the square root. So I'm going to square root. Okay, and when you take the square root of r squared, what do you get? R. Okay, and then Avery, do you think you could tell me what the square root of 25x squared is going to be? You're close. So the square root of x squared is what? X. What's the square root of 25? Yep, so it'll be 5x. Okay, so 25 is a perfect square, so the square root of 25 would be 5. Square root of x squared is going to be x. Okay, so now that we know that our radius is 5x, remember, we're not trying to find the radius, we're trying to find what? The circumference. So for step 2, we are going to plug in r equals 5x to find the circumference. Okay, and make sure you are writing down the notes with me. Okay, writing down the steps that you do is just going to help you cement that in your mind. Okay, you remember more that you write down versus what you just read. Okay, so those are there to help you. That way you can look back and you have a little step chart. Use the area formula to find the radius, plug in to find the circumference. Okay, so then the circumference is 2 pi r. So then this will be 2 pi times 5x. Now when you're multiplying these together, okay, if you have two numbers, you do want to multiply them. All right, Jana, do you want to tell me what you think this would be?
10x.
Yep, okay, so it's going to be 10x and then pi. So 2 times 5 is where you get the 10. You have 1x and then you have 1 pi. And then it's important that you use your measurements. So the circumference is measured in what? And this one it'll just be feet, right? Just like the perimeter. The only time you'll have feet squared is if you're measuring what? The area. And then if we do the volume, it would be feet cubed. Okay, so the next thing we're going to talk about are regular polygons. Okay, so one thing we know is that the center of a regular polygon is equidistant. It is equidistant from the vertices. Now, if you had to describe what equidistant meant, could you guys tell me? Yeah, it's just the equal distance, right? So the center of a regular polygon is going to be the same distance, okay, from all of the other sides. So let's show that with a hexagon. Can you guys draw a hexagon with me? Oh, I think I have one on my template. So a hexagon has how many sides? 6. Oh, what a lovely hexagon. Okay, and then it's saying that the center is equidistant from its vertices. Okay, so here's my center. One of my vertices is going to be here. If it has 6 sides, do you guys know how many vertices it has? 6. Okay, so the distance from the center to this vertex is the same as from the center to this vertex. Okay, really this shape is going to be full of what shapes? Triangles. Yes, there are. Okay, so what that's saying is that this distance is the same as this distance, which is the same as this, which is the same as this, which is the same as this, which is the same as this. So what type of triangles do I have? I have isosceles triangles. Okay, so if they're isosceles, if the two sides are the same, then we know, yeah, the angles across from them are the same. Okay, so that's going to come in handy. All right, now, this is most likely a new word for you. Have you guys heard of an apothem? Okay, so the apothem is the distance from the center to a side. Okay, so we'll do another hexagon and write out what that's going to look like. Okay, so it's going to be the center to a side. So if I just want to draw this to this side here, okay, and what it does is it forms a right angle with the side. So that would be your apothem. All right, so one other thing we have to know before we start finding other areas is the central angle. Okay, so the central angle of a regular polygon has its vertex at the center. Oh, thanks. Has its vertex at the center, and its sides pass through the consecutive vertices. Okay, and of course we'll draw another picture as well. Okay, now to find out what the central angle is, you are going to take 360 degrees and divide that by n, where n is the number of sides. Okay, so if we use my hexagon buddy, okay, then the central angle is going to be right here. Okay, and really every single one of these would have this central angle. So there would be 6 different central angles. Okay, I'm just showing you one of the 6. All right, now the reason why we wanted to know all of that is so we could find the area of a regular polygon. So to find the area of a regular polygon, we have to know what the apothem is, and then we also have to know what the perimeter is. Okay, so the area of a regular polygon is equal to 1/2 multiplied by the apothem multiplied by the perimeter. Okay, so the area equals 1/2 times the apothem times the perimeter. All right, so now we are going to find the area of a regular polygon. So it says find the area of each regular polygon to the nearest tenth. Okay, so that's where we're going to be rounding, is to the nearest tenth. So we have a regular heptagon, and a heptagon has how many sides? 7, right, with a side length of 2 feet. Okay, so it's a regular heptagon. The side length is 2 feet. I'm just going to label one side as 2 feet. Okay, so keep in mind that what we're going to have to know is the apothem and the perimeter. Okay, we can actually find the perimeter very quickly with this one. What would we do? 7 times 2, right? There's 7 sides, 2 feet. The perimeter is going to be 14. Okay, and you might not always be able to find the perimeter first. So what we're going to start by doing is we're going to find the central angle. So remember, the central angle is going to be this angle here in the middle. So my n is going to be 7, so I'm going to do 360 degrees divided by 7. Okay, so I will need my calculator for this one. It is not a nice even value. It's going to be a decimal. Oh, that one doesn't have that. Okay, so we'll do 360 divided by 7. Okay, and then we can go ahead and round this one to the nearest tenth. So 51.4. Okay, so that means this angle here is 51.4 degrees. Sorry, that is a terrible arrow. Okay, and then the next thing we're going to do is find the apothem. And this is where the plot thickens. So what I'm going to do is I'm going to draw this little triangle out here, okay? So remember, this is an isosceles triangle, okay? So you're going to have 2 of the sides are equal to each other. Right, now we know this angle here is 51.4 degrees. We also know what this is. What is this base? 2. This is going to be 2 feet. Okay, to find the apothem, what you want to find is this line right here. The apothem. Apothem kind of sounds like a little kid trying to say opossum, doesn't it? It's an apothem. It's okay, you can smile. That was a good joke. Okay, so what we're trying to find is the A. All right? So what the apothem does is it bisects the side and the central angle. Okay, the apothem bisects the side and the central angle. So then what I usually do is I just draw half of this triangle. So if I'm just looking at half of it, right, the apothem is going to form a 90-degree angle here. What is half of my 2 feet? 1. Now sometimes it might be a decimal, and that's okay too. Okay, that one just happened to turn out nice. Now I also get to cut this angle in half. Okay, so half of 51.4 is going to be, yeah, good. It'll be 25.7, right? Half of 50 is 25. Half of 1.4 is going to be 0.7. Okay, so this angle is 25.7 degrees. Now, if I want to find A, what could I use to find that? Yeah, I could use SOHCAHTOA, right? What part of that? The tangent. Because I have an angle, what is the relationship between this angle and this side? It's opposite. This side is the adjacent. Okay, so you can absolutely use the tangent. Okay, so the tangent of 25.7 degrees is going to equal the opposite, which is 1 foot, over the adjacent, which is A. Now remember, if A is on the bottom, when you cross multiply, we're not going to calculate it yet, we will in a minute. If you are multiplying both sides by A, then you're dividing both sides by the tangent of 25.7. So this is 1 divided by the tangent of 25.7. Okay, remember if it's on top, you multiply them together. If the variable's on top, you multiply them together. If the variable's on the bottom, you don't. Okay, so some of you look like you're unsure about that, so I'll write it out for you first. You don't have to write this part out. So if I'm solving for A, A's in the denominator, right? So I would multiply both sides by A, and on this side, I'd get 1. On this side, see how I have A times the tangent of 25.7? So what I would do now is divide by the tangent of 25.7, right? So I'd get A by itself, and then I'd have to divide this by the tangent of 25.7. Okay, so since we've done that a lot, right, we start to realize, oh, anytime A's on the bottom, we're going to be dividing. All right, so now what we're going to do, now that we know this is our apothem, we really don't want to round this until the very end. So we're going to keep this as our apothem for right now. And then we're going to go to step 3 where we're going to find the perimeter. Okay, which in this case, your perimeter is going to be simple to calculate. It's just going to be your side length times your number of sides. So we already talked about this. Our side length is 2 feet. There are 7 sides, so this would be 14. So now we can calculate the area. Okay, so the area is 1/2 times the apothem times P. The apothem is 1 over the tangent of 25.7 degrees times 14. Now, see what I would do is notice how you have an even number here for the perimeter. What's 14 times 1/2? 7. So this is like 7 times 1 over the tangent of 25.7 degrees. If you multiply this by 7, think of it as 7 over 1. Your area is just going to be 7 divided by the tangent of 25.7 degrees. And then I can go ahead and round that to the nearest tenth. Okay, so do make sure that you're in degree mode. Okay, and then we're going to do 7 divided by the tangent of 25.7. Okay, so then that's going to round to about 14.5 feet squared. Okay, so it's really important that you're putting your units on. Okay, so for every problem here, you should have your units. Okay, what are we going to remember to put for every problem? Units. Okay, good. So that's going to be in feet squared. All right, so this one's definitely going to take some practice. That's why I broke it up into 4 steps for you. Okay, so you have those 4 steps that you can look back on. Okay, now for B, this is going to be a similar process. And I'm going to help you through it, but I'm also going to let you take the lead on some of these. Okay, so you're trying to find the area of a regular dodecagon with the side length of 5 centimeters. Okay, so if it's a dodecagon, how many sides does it have? 12. Okay, and then Jared, what's our first step? What's the first step that we did last time? Yep, good. So I'm going to give you guys a couple seconds to find that. Find the central angle. And then if you've already done that, you can go on to step 2. Okay, Baron, tell me how you're finding the central angle.
360
Yep, and in this case it'll be?
45.
No, you're going to divide by what number? 12, right? Because there's 12 sides. Right, so with this one, what's 36 divided by 12?
33.
Okay, so then 36 divided by 12 is 3, right? So then, yeah, you know it's 30 degrees. Okay, so then what I'm doing for step 2, Kaylin, what am I doing for step 2?
Isn't that where you find your, what's it called? The, apothem?
You're going to find the apothem. Now, I drew out the full triangle first, and then I drew the half triangle. You can really just draw the half triangle, right? If you know what your side length is, you're going to just cut that in half. Okay, so I want you to label your triangle. Okay, so Brandon, what is your side length going to be here?
2.5.
Okay, and then Hope, where's this 2.5 coming from? Okay, yeah, so you're going to divide the side length by 2, right? Okay, and then Tina, what's this angle going to be? Okay, where'd you get that from? Okay, so it's going to be half of your central angle. Okay, now this is your apothem. So we are going to set up our equation to find what that is. Okay, so what are we going to use? Which part of sine, cosine, or tangent? We're going to use the tangent. Okay, Ethan, can you tell me what your equation is going to be? Good. Okay, 2.5 over A. Okay, so then Madison Georgowski, did I say that right? Thanks. Okay, will you tell me what A is going to equal?
2.5 over 10.
Good. 2.5 over the tangent of 15 degrees. Yep. Okay, and then in step 3, Maddie Harris, what are we going to find for that? Yeah, the perimeter. Yep, and how do we do that? How are you going to find the perimeter, Maddie? That. You say you're not sure? Okay, so do we know what the side length is? Do we know what the side length is? Yeah, right? Okay, so the perimeter is just going to be the distance around your shape. So if you have 12 sides and each side is 5, what can we do to find it?
Multiply number.
Okay, yep, so you can multiply that together. So you can just do the 12, which is the number of sides, times the side length. Okay, so this is the number of sides. This is the side length. Okay, which means your perimeter is going to be 60 centimeters. All right, so then that brings us to finding the area. So when you calculate the area, you're going to do 1/2. And if you guys want to write like the 1/2 next to the 60, so you can do that first, you can. Because half of 60 is going to be what? Half of 60 is going to be 30 times 2.5 divided by the tangent of 15. Okay, and so what I would do first is I would do 2.5. 2.5 divided by the tangent of 15. And then you're just going to take that value and multiply it by 30. And then we're still going to be rounding to the nearest 10th. So 279.9. And then what are my units for this? Good. Centimeters squared. Okay, so then for 9.2, bless you, we're going to do 10 through 12, and then 14 through